Okay, we did problems 1 through 3. Let's look at number 4 here. Now this is 4. We're going to do the same thing here, so let me copy that. F of x equals 2x squared minus 7x plus 8. And B, we're looking for the rate of change when x is equal to negative 1. So once again, we're going to set it up as the limit as h goes to 0 of f of x plus h minus f of x. And all of this is divided by h. So this is the limit as h goes to 0 of 2 times x plus h squared, replace the x with x plus h, minus 7x plus h, and again replace the x with x plus h, plus 8, and then we subtract the original function, 2x squared minus 7x plus 8. All divided by h. I'm going to expand that out. And this will be 2x squared plus 2xh plus h squared minus, I'll leave this like that for now, x plus h plus 8 minus 2x squared minus 7x plus 8 all over h. Now if I distribute both of those terms across, I get 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 8 minus 2x squared plus 7x minus 8 all over h. And we can clean this up. 2x squared minus 2x squared, negative 7x, positive 7x, 8 minus 8. And this is divided by h. So I can go through and do that, something with that too. The h disappears here. This is h squared, so one of those h's is gone. And this is gone. So what I'm left with is the limit as h goes to 0 of 4x, that takes care of this one, plus 2h, that takes care of this one, and let's see, what else do I have here, minus 7, takes care of this one, and everything else is gone. Now I'm going to let h go to 0. That means I'm going to be left with 4x minus 7. So therefore, the instantaneous rate of change of f of x is 4x minus 7. But again, I'm concerned about x equals negative 1. At x equals negative 1, the instantaneous rate of change is 4 times negative 1 minus 7, which is negative 11. That takes care of number 4. Now let's look at number 5. Number 5 is f of x equals x cubed plus x minus 2, and I'm concerned about what happens when x equals 2. Now that's a cubic. We have to expand that out. Now one of the things we can use for the expansion is something called Pascal's triangle. I don't know if you remember this or not. But we start with 1. This means the exponent is 0. This is when the exponent is 1. This is when the exponent is 2. And this occurs when the exponent is 3. Now these are the coefficients here. So when we've got a cubic like this, the coefficients after we expand it will be 1, 3, 3, and 1. So we'll have 4 terms. So let's write this out. The limit as h goes to 0 of f of x minus h, plus h, not minus x, minus f of x all over h. So this is the limit as h goes to 0 of x plus h cubed plus x plus h minus 2 minus x cubed plus x minus 2 all over h. Now this is where I'm going to use Pascal's triangle to expand this. The limit as h goes to 0. Now the first coefficient of the first x term is going to be 1, so this is just x cubed. The next coefficient is 3, but if x is cubed here, it has to be squared here, but these exponents all have to add to 3, so I have an h to the first power. Second coefficient is 3, x3, x2, so this has to be x to the first, and then h has to go to 2 because all the exponents have to add to 3. And the last term is 1 h cubed plus x plus h minus 2, just remove the parenthesis on that, minus x cubed plus x minus 2 all over h. Now this is x cubed minus x cubed, so that cancels out. Here's an x minus an x, so that's gone. And this is a negative 2 minus a negative 2 becomes negative 2 plus 2, so those are gone. And I'm left with this. The limit is h, well, let's clean up the h2. If I divide by h, that's gone. One of these is gone. This is down to a 2. That's gone. And I'm just left with 3x squared plus 3xh. Plus h squared. And what else do I have here? Should be something else here, I think. 3x squared, that's this one. It's over h. This is an h squared. Oh, h divided by h is going to be a 1, so this is a 1 here. That's there. Now, if we let h go to 0, what we're left with is 3x squared plus 1. So therefore, the instantaneous rate of change for f of x is 3x squared plus 1. Now when x equals 2, the instantaneous rate of change is 3 times 2 squared plus 1. 2 squared is 4, 3 times 4 is 12, plus 1 is 13. And we're done. Now, some people had trouble with number 6, and I think it was just because that's a rational function there. So this one says f of x equals 5 divided by x minus 3, and we want to see what it is at x equals 1. Okay, so we're going to look at the limit as h goes to 0 of f of x plus h minus f of x. I didn't need both of those parentheses all over h. This becomes the limit as h goes to 0 of 5 over x plus h minus 3 minus 5 over x minus 3, and all of this is divided by h. Now some people miss this, I think, because we have the two denominators in here, but format's still the same. Now we know from algebra and even some arithmetic that we can't combine fractions unless we have a common denominator. So to get a common denominator, I'm just going to multiply each term by the opposite denominator. 5 over x plus h minus 3 times x minus 3 over x minus 3 minus 5 over x minus 3 over x plus h minus 3 over x plus h minus 3. Now don't forget, all of this is still divided by h. Now you can see these two denominators are going to be the same here. So I'm only going to write them one time when I rewrite this. Limit is h goes to 0. 5 times x is 5x minus 15 minus 5x minus 5h plus 15. All of this is divided by this common denominator now. X plus h minus 3 times x minus 3. And again, all of this is divided by h. Now, 5x cancels out. This negative 15, this should be a 15 here. 5 times 3 would be 15. Negative 15 and a positive 15 cancels out. And now we need to clean this up a little bit. The limit as h goes to 0, and we're going to have negative 5h over x plus h minus 3 times x minus 3, all divided by h. Now just for convenience here, I'm going to write this as h divided by 1. Now when you've got when you're dividing a fraction by a fraction, you can just flip it and multiply. So I'm going to do this then. Limit as h goes to 0 of negative 5h divided by x plus h minus 3 times x minus 3 times 1 over h. I flipped that. The h's cancel out. Now I'm left with the limit as h goes to 0 of negative 5 over x plus h minus 3 times x minus 3. But remember, this h is going to 0, so now I'm left with negative 5 over x minus 3 squared. So therefore, my instant rate of change of f of x is negative 5 over x minus 3 squared. And when x equals 1, the instant rate of change is negative 5 over, plus 1, isn't it? Yeah. 1 minus 3 squared is negative 5 over negative 2 squared, which is 4. And that's my answer, negative 5, 4. Okay, let's try to squeeze one more in here. Let's see, that was 5, 6, 4, 5, and 6. Okay, we're going to stop there on this one.